Hi everyone, welcome to the finite element analysis of beams part 1. In this we are studying the introduction and shape function. So learning outcome for this session is to derive the shape function for a beam element and to know the variation of those shape function in the form of graphical representation. Now beam is a long structural member, relatively a smaller cross-sectional area, and it is applied with the transverse loading. So beams are the most common type of structural components particularly used in mechanical and civil engineering. So beam is a bar-like member whose primary function is to support the transverse loading and carry it to the supports. Now we'll move to the shape function for the beam element. So before moving to the shape function for beam element, so let us see what is this shape function. We already discussed this in the previous sessions. So shape function is an interpolation function which is used to interpolate the element displacements and element nodal displacement. That means if at all we want to find out the displacement at any random distance in the uh, element in the FEM, so there we need to take the help of the shape function. It will interpolate the displacement which is there in the element with respect to the displacement which is there at the element nodes. So for that we need to choose a suitable shape function for those particular elements what we are using in the FEM. Now as we are dealing with the shape function for the beam element, so let us consider a beam element with two nodes, and at each node we are going to consider a 3 degrees of freedom, that is axial and transverse displacement as well as slope. Now this is a beam element having the vertical displacement v1 and v2 at node number 1 and 2 respectively. Similarly I have a slope which is there at node number 1 and 2, that is theta 1 and theta 2, and this is v1 and v2, that is vertical displacement. Slope is theta 1 and theta 2. So this is the beam which is shown both in local coordinate as well as global coordinate. The local coordinates are the value of zeta, which is -1 at node number 1 and +1 at node number 2, and from the reference the location of node number 1 is at the distance of x1 and the location of node number 2 is at the distance of x2. This is shown in the global coordinates. Now we need to define the four shape functions, that is n1, n2, n3, n4, such that v and dv by dx, where v is the displacement and dv by dx is the slope, which gives the transverse displacement and so slope for the beam respectively. Now to let us start with the n1. N1 is the shape function which is related to the v1, that is vertical displacement. Similarly n2 is the shape function which is related to the theta 1, that is for the slope. Similarly n3 is the shape function which is related to v2, and n4 is the shape function which is related to theta 2. So let us start with the n1 first. So we will consider n1 in the form of a polynomial function from the properties of the shape function, that is fourth property. The shape function are also a polynomial function of same order what we are going to consider for the displacement function. Therefore n1 is equal to a0 plus a1 into zeta plus a2 into zeta square plus a3 into zeta cube. So this is the polynomial function in the form of local coordinate, that is zeta I am going to consider. Let us say this is an equation number 1. Then by differentiating this n1 with respect to zeta, I am going to get the another equation, that is equation number 2. So a0 is constant, so it becomes 0. The differentiation of zeta, I mean this a1 constant, differentiation of zeta is 1. Therefore I'll get this a1. Next, the differentiation of zeta square is 2 zeta, this a2 as it is, therefore it is 2 a2 zeta. Similarly, differentiation of zeta cube is 3 zeta square a3, so this is 3 a3 zeta squares. That is what my second equation. So in the next, uh, as we are having the four unknowns here, that is a0, a1, that is a0, a1, a2 and a3, we need to find out these four constants, so that by substituting these four constants we are going to get the value of n1. So for that we need to consider the boundary condition. So let us go with the boundary condition, that is when x is equal to x1 I will get the node number 1. Similarly when x is equal to x2 I will get the node number 2. So now I'll put the values for n1. So n1 is equal to 1 at node number 1, and the same n1 is equal to 0 at node number 2. This is from the first property of the shape function. It says the value of shape function at its own node is unity, and the same shape function at other node it will become 0. So this is the property of the shape function. It says Therefore n1 is equal to 1 at node number 1, and n2 is equal to, I mean n1 is also equal to 0 at node number 2. Therefore I am substituting the value of zeta minus 1 at node number 1 and the value of zeta plus 1 at node number 2. This is one condition. Then similarly we need to put the value for the slope also. Therefore dn1 divided by d zeta is a slope. Now as we are doing the shape function n1 which is related to the vertical displacement, therefore there is no question of slope, so automatically slope will become 0 at node number 1 as well as at node number 2. So slope at node number both 1 and 2 it becomes 0, but at that location the value of zeta I need to substitute. That means at node number 1 the value of zeta is minus 1, and at node number 2 the value of zeta is plus 1. So these are the four condition we need to substitute in equation number 1, so that we are going to get the four equations. By solving those four equations we can get the fourth constant. Let us see how we can solve those equations to get the four constants. So when I substitute n1 is equal to 1 in equation number 1, I'll get 1 is equal to, so as I have the value of zeta is minus 1, this is constant a0 and this is associated with zeta, therefore I'll get a negative sign, and this is associated with zeta square, therefore I'll get a positive sign, and this is associated with zeta cube, therefore once again I'll get a negative sign. So this is what my equation number 3. Similarly on the other side, when I substitute the values of n1 and zeta at node number 2, so as zeta is plus 1, all constants are associated with positive sign, but at left hand side I have n1 value is 0, therefore this is my 0. So this is equation number 3 and this is equation number 5. Similarly I need to substitute the values of slope at node number 1 and 2 along with the zeta values. You know the slope equation, that is what we obtained as equation number 2 in the previous slide. So there when I substitute the value of dn1 divided by d zeta at node number 1 is 0, that is what I have substituted here. Then when I substitute the values of zeta, that is minus 1, so this is associated with zeta square, therefore I am going to get a negative sign, sorry, this is associated with zeta, therefore I get a negative sign, and this is associated with zeta square, therefore I'll get a positive sign. Similarly when I come for the value at node number 2, so once again dn1 divided by d zeta is 0, that slope is 0 at node number 2, and I substitute the value of zeta as plus 1, therefore all the constants are associated with positive sign. So these are the four equations I obtained. I need to solve these four equations to get the four unknowns, that is a0, a1, a2 and a3. Now how to solve that? First we need to add the equation number 3 and 5. When I add the equation number 3 and 5, minus a1 plus a1 will be get cancelled. Similarly when I add this minus a3 plus a3 will be get cancelled, left out with a0 and a0, it is 2a0, and a2 and a2 it is 2a2, that will be equal to 1. So that is what I have shown in the next equation. So that is 2a0 plus 2a2 is equal to 1. Therefore a0 plus a2 is equal to 1 by 2. After taking those 2 common and send it to the other side, a0 plus a2 will be equal to 1 by 2. Let us take this as an equation number 7. Then similarly we need to add the equation number 4 and 6. When I add the equation number 4 and 6, so minus 2a2 and this plus 2a2 will be get cancelled, left out with a1 plus a1, it is 2a1, then 3a3 plus 3a3, it will be 6a3, that will be equal to 0, because both side I have 0, 0 plus 0 it is 0. So that is what I am getting here. So 2a1 plus 6a3 is equal to 0, therefore a1 is equal to minus 3a3. After taking common and sending to that side, a1 will be equal to minus 3a3. Let us take this as an equation number 8. Now substituting this value of a1 in equation number 5, what is my equation number 5? Equation number 5 is an shape function equation which is there at node number 2. So that is what it is, a0 plus a1 plus a2 plus a3 is equal to 0. That is the equation where I need to substitute the value of a1. a1 is minus 3a3. When I substitute this, so a0 as it is, a2 as it is, then this minus 3a3 and plus a3 it will become minus 2a3. So that is minus 2a3, a0 plus a2 minus 2a3 is what the equation after simplification. But I know the value of a0 plus a2 is 1 by 2. That is what my equation number 7 in the previous slide. Therefore let us substitute the values of a0 plus a2 in equation number 7, that is 1 by 2. So that is 1 by 2 and this minus 2a3 as it is. Then after simplification I'll get the value of a3, that is 1 by 4. This is the first constant I am getting. Then next what I need to do, I need to substitute this value of a3 in equation number 8 here, and I substitute a3 1 by 4, so it will become minus 3 by 4. Therefore my value of a1 is minus 3 by 4. Now once this is done, now I obtain the two constants, that is a1 and a3. So let us substitute these two values in equation number 6. What is my equation number 6? It's a slope equation which is there at node number 2. That is what a1 plus 2a2 plus 3a3 is equal to 0. Therefore a1 is minus 3 by 4 and my a3 is 1 by 4. Therefore here 3 is there, therefore it becomes 3 by 4. So it is minus 3 by 4 and plus 3 by 4 will be get cancelled, left out with 2a2, and that will be equal to 0. So that is what I obtained the another constant, that is a2. Now I need to get the value of a0. Therefore substituting this value of a2 in equation number 7. What is my equation number 7? Here I have substituted a0 plus a2 is equal to 1 by 2. Therefore there I need to substitute the value of a0 as 0. Therefore I have substituted here the value of a0 as 0. Therefore a0, sorry, a2, the value of a2 as 0. Therefore a0 plus 0 is equal to 1 by 2. Therefore a0 is equal to 1 by 2. So therefore that is what my fourth constant I am going to get. So these are the values of the four constants were calculated by solving those four equations. And now let us substitute these four constants in equation number 1. When I substitute these four constants in equation number 1, I am going to get a0 as 1 by 2. Then a1 is minus 3 by 4 into zeta. a2 is 0 zeta square. Then a3 is 1 by 4 into zeta cube. Now from these I'll take it 1 by 4 common. Only the first term which is not there with 1 by 4, it is 1 by 2. Therefore I'll multiply 2 here in the first term. Then minus 1 by 4 already taken, left out with minus 3 in terms of zeta. Then this is the term which is get eliminated because of 0. Then next is 1 by 4 already taken, so left out with plus zeta cube. So this is the equation we are going to obtain for n1. That is what my shape function for n1 in terms of zeta. Now let us see how this shape function is varying. Here the at node number 1 I have a value for n1 is 1. Therefore this is a value of 1. At that location I don't have any slope, therefore slope is 0. When I come to the other node, my n1 is also 0 and my slope dn1 divided by d zeta is also 0. Therefore this curve is approaching to 0, that is on the baseline when it comes to the node number 2. So this is how the shape function n1 is varying. Now similarly we need to derive the shape function n2. For that, once again let us consider n2 in the form of polynomial function. Same term what we have considered in the previous while deriving n1. Similarly, when I differentiate this n2 with respect to zeta, this is the equation I am going to get. Now I need to once again consider the boundary condition. Now here there is a slight change in the boundary condition because I am deriving the shape function n2. Please remember n2 is the shape function which is related to the slope which is there at node number 1. Therefore when I go with normal n2 is equal to 0 at node number 1, and this n2 is also 0 at node number 2 because this is not related to the slope. Slope should be dn2 divided by d zeta. So that is dn2 divided by d zeta at node number 1 is the value 1 because now I am deriving the shape function n2 for the slope. Therefore at that location the value of shape function will become 1 and at other node it will become 0. Means my dn2 divided by d zeta will be equal to 0. And let us substitute the same value of zeta at node number 1 as minus 1 and at node number 2 it is plus 1. Now once again substituting the value of n2 in equation number 1 for both node 1 and 2. Now what I am going to get? Same thing I am going to get because this is associated with zeta minus and this is associated with zeta cube minus. Here zeta is all plus 1, therefore all the constants are associated with plus. Please remember in the previous when I am deriving n1, my n1 is having a value 1, therefore I have considered 1 here, but here n2 is 0 on the left hand side at node number 1 as well as at node number 2 also my n2 is 0. Therefore both sides I'll get 0. That is what I am going to consider equation number 3 and 5. Similarly I need to put the values of slope in the slope equation, that is equation number 2 here. When I substitute, once again this is associated with the zeta, therefore I'll get a negative sign, and this is associated with zeta square, therefore I'll get a positive sign. But here dn2 divided by d zeta is having a value 1, so that will be equal to 1. Similarly at node number 2 the value of dn2 divided by d zeta is equal to 0, substituting the value of zeta plus 1, so all constants are associated with the plus. Now we'll apply the same procedure to solve the equations to get the four unknowns. Now once again first I need to add the equation number 3 and 5, then I need to add the equation number 4 and 6 to get the four constants. Now same way here my minus a1 plus a1 will be get cancelled, minus a3 and plus a3 will be get cancelled, left out with the 2a0 plus 2a2 is equal to 0 because now both sides I have 0. That is what I have shown here. these negative positive values will be get cancelled. Similarly, when I solve equation number 4 and 6, minus 2a2 and plus 2a2 will be get cancelled, left out with same thing, 2a1 plus 6a3 is equal to 1 now. That will be equal to 1. So that is what I have shown here. When I add equation number 3 and 5, I am going to get 2a0 plus 2a2 is equal to 0. Therefore, a0 plus a2, after taking 2 and sending to that side, it will become 0. Therefore, my a0 will be equal to minus a2. So let us take this as an equation number 7. Then similarly, adding equation 4 and 6, there minus 2a2 plus 2a2 will be get cancelled, left out with the 2a1 plus 6a3 is equal to 1 now. Therefore, a1 is equal to 1 by 2 minus 3a3. After taking common and sending to that side, this is the value of a1, that is 1 by 2 minus 3a3. So take it as an equation number 8. Now substituting the value of a0 and a1 in equation number 5. Now what is my equation number 5? It is a shape function equation at node number 2 for n2. So that is given by a0 plus a1 plus a2 and a3. So a0 is nothing but minus 2a2 and a1 is 1 by 2 minus 3a3, a2 a3 as it is. Now after simplification, here minus 2a2 plus 2a2 will be get cancelled, then left out with 1 by 2 minus 3a3 and plus a3 will be minus 2a3. So 1 by 2 minus 2a3. Therefore, this is the only one equation, only one unknown. When I solve this, I am going to get the value of a3, that is 1 by 4. That is the first constant I am going to get. That value is 1 by 4. Similarly, substituting the value of a3 in equation number 8, I am going to get the value of a1. That is what, 1 by 2 minus 3a3 as it is. A3 is nothing but 1 by 4, then it becomes 3 by 4. When I solve 1 by 2 minus 3 by 4, it is minus 1 by 4. So the value of a1 is minus 1 by 4. Now I obtain the second constant value. Similarly, I need to substitute the value of a1 and a3 in equation number 6. Once again, my equation number 6 is what? It's a slope equation which is there at node number 2. Therefore, it is a1 plus 2a2 plus 3a3 is equal to 0. Therefore, a1 is minus 1 by 4 and 2a2 as it is. A3 is 1 by 4. Therefore, it becomes 3 by 4. So when I solve this, I'll get the value. One equation, one unknown is there. Therefore, when I solve this equation, I'll get the value of a2, and that value of a2 is minus 1 by 4. Now, this is my third constant. Then I need to get the value of what, a0. So substituting that value of a2 in equation number 7, I'll get the value of a0, and that value of a0, that is equation number 7 is nothing but a0 is equal to minus 2a2. Therefore a2 value is minus 1 by 4. So minus of minus, it will become plus 1 by 4. So therefore the value of a0 is plus 1 by 4. So this is my fourth constant. So now I obtained all the four constants. That is, these are the four constant values. So these four constants values I need to substitute in equation number 1. When I substitute, this is a0 is 1 by 4. Then a1 is minus 1 by 4 into zeta. A2 is minus 1 by 4 into zeta square. And a3 is 1 by 4 into zeta cube. Now everywhere I have 1 by 4 common. So I'll take that 1 by 4 common. Therefore I left out with 1 minus zeta square plus zeta cube. This is the equation. So this is what my shape function for the slope which is there at node number 1. Now let us see the variation of that shape function in the form of graphical representation. Therefore at node number 1 the value of n2 is 0, but where the slope I am having a value of unity, therefore dn2 divided by d zeta is nothing but slope, that is having the value of 1. Therefore my curve will start like this. Then when I come to the node number 2, now my n2 is equal to 0, and dn2 divided by d zeta, that is slope at node number 2 is 0. Therefore it is approaching to the baseline. So this is a variation of that shape function. Now similarly, we need to derive the shape function n3. So n3 is what? It is a shape function for vertical displacement which is there at node number 2, that is v2. And v2 is vertical displacement at node number 2. Similarly, v1 is the vertical displacement which is there at node number 1. Therefore my n3 is almost similar to n1. Therefore, by substituting the value of n3, slope and zeta at node number 1 and 2, once again we are going to get the four equations. So solving those four equations, will get the shape function n3. And this is what my shape function n3 by solving those four equations. Now n3 is equal to 1 by 4. It is 2 plus 3 zeta minus zeta cube. Therefore, this is similar to n1, only there is a change of sign here. So there it is minus 3 zeta plus zeta cube. Now here it is plus 3 zeta minus zeta cube. That is what the shape function n3. Now if you see the variation of that shape function, now n3 is what? It is the shape function which is there for vertical displacement at node number 2. Therefore at node number 2 that n3 is having a value 1 because it becomes the own node for that shape function, but that n3 will become 0 at the other node. Therefore now node number 1 will become other node for n3. Therefore this will be equal to 0. Therefore similarly when I come for the slope dn3 divided by d zeta, that is the slope is 0. Therefore I don't have any slope at node number 2. Similarly dn3 divided by d zeta, that is slope is 0 at node number 1. Therefore this is a curve and approaching to the baseline. Now that is n3. Now I need to do the n4. Now once again n4 is what? It is the shape function related to the slope which is there at node number 2. Now once again it is similar to the slope what you are derived for node number 1, that is theta 1. And similarly substituting the value of n4, then slope and value of zeta at node number 1 and 2, once again we are going to get the 4 equation. Solving those 4 equations we will get the value of n4. So this is what my value of n4. Once again it is similar to the value of n2 what you are derived for shape function at node number 1, only there is a change in the sign. There it is plus 1 plus zeta minus zeta square plus zeta cube, something like that. So there the sign is going to change but the terms are same. Now to know the variation of this shape function in the form of graphical representation, now once again I have a n4 is nothing but the shape function for the slope. Therefore at node number 2 I have dn4 divided by d zeta value is 1, whereas the n4 is 0. Now when I come for the other node, the value of shape function, I mean the value of n4, that is slope at other node, it will become 0. That is dn4 divided by d zeta is equal to 0. Then n4 is also equal to 0. Therefore my curve is varying and approaching to the baseline. So this is a variation of that shape function n4. Now whatever the 4 shape function we are derived n1 n2 n3 n4, these 4 shape functions we call it as an Hermite shape functions. Now whatever the shape functions we are derived considering the boundary condition, those boundary conditions we can represent in the form of table. So that table I mentioned here. So this is n1, this is dn1 divided by d zeta, this is n2. Similarly differentiating that n2 I'll get this, n3 differentiating n3 I'll get this, n4 and I'll differentiating n4 I'll get this. So when I come for the n1 at node number 1, so these are the two things which are related to the node number 1. So the n1 is what? It is the shape function related to the vertical displacement at node number 1. Therefore at node number 1 the value is 1 and remaining 3 values are 0. So that is what the 4 boundary conditions I am going to get. So these are the 4 boundary conditions for the calculation of n1. Similarly when I come for the n2, what is n2? It is a shape function related to the slope. My slope is here and that slope is there at node number 1. Therefore that value is 1 at node number 1 and remaining 3 will become 0. So this is what the second 4 set of boundary condition to get the value of shape function for the slope. Similarly when I come for the third one, n3 is the slope, I mean shape function for vertical displacement which is there at node number 2. Therefore at node number 2 under n3 I have a value of unity and other 3 terms will become 0. So these are the 4 set of boundary conditions to get the 4 equations. Solving those 4 equations I'll get the shape function n3. Similarly coming to the last one, n4 is related to the slope. Therefore dn4 divided by d zeta is the slope which is there at node number 2. Therefore under this I have a unity and remaining all 3 will become 0. So these are the set of 4 values to get the 4 equations. So this is a table which is utilized to get the shape functions by substituting the boundary condition. So thank you for watching.